radicals. Solve the equation square root of x plus 9 minus square root of 2x equal with 3. So in this case we have two radicals. There are many ways how to solve it, but let me solve in one way that I think it makes sense, and we used those strategies in our class. So for instance, if I have two radicals in one side, I'm gonna put one radical in the other side and one, I believe, in the other side. So let's say square root of x plus 9, I'm gonna leave in this side here, x plus 9, and the other I'm going to put in the other side. So here I'm going to put a 3. And if I'm putting this in the other side, it's going to change the sign, and the sign is going to be plus square root of 2x. So this is going to be 2x, and now what I'm going to do now, we are going to square both radicals or both sides. And if I'm squaring the both sides, then here is going to be x plus square root of x plus 9 x plus 9. I'm trying to write a little smaller because of this problem is going to be a little bit a longer process. And here is a 3 plus square root of 2x. So I'm squaring both sides. This square root here, this square with the index is going to cancel, or to simplify, better to say, and what remains here remains just the x plus 9. And in other side, I'm going to have a 3 plus square root of 2x. Because we have a square here, so this we can write as a multiplication of 3 plus square root of 2x times 3 plus square root of 2x. Both sides, so it's the same. And I'm going to take a little bit shortcut because it's not going to fit all the process if I write with the long steps in this small place. So here, let's say I write x plus 9 because we cannot do anything else right now. But in the other side, if we are distributing those binomials, if we are distributing, if we are multiplying, what's going to happen? 3 times 3 is 9. 3 times square root of 2x is 3 times square root of 2x. Then I'm multiplying square root of 2x times 3 and square root of 2x times square root of 2x. So sometimes when we are using the terminology, we are foiling. Or we can FOIL, or we can multiply, we can distribute, so we can use whatever term you want, but the process we have to respect the process. So if we are writing everything, if we are distributing, or if we are FOILing, the final form is going to be in this way: 9 plus times 6 times square root of 2x, and square root of 2x times square root of 2x is plus 2x. So now we are in better position than we were in beginning, and we are trying to simplify further until we are getting in the position to solve it for x. So right now here, as we see, we can subtract here by minus on both sides, because this minus 9 is going to cancel because in both sides is the same. And now x's I'm going to put in one side, and radical I'm trying to isolate the radical, like we solved the problem with equation with one radical in one side. So we are respecting the same process now. We are trying to isolate this radical in one side. So let's take this in other side, minus 2x both sides, and here minus 2x. And now we are simplifying a little bit this process here. So this here we can cancel. This cancels. And this cancels too, minus 2x, 2x. What remains in this side? In this side remains just 6 times square root of 2x. So this side remains just a 6 times square root of 2x. So now every step that we are doing, we come to the in a better position. X minus 2x is a minus x. And now we are in much in better position. What we do now, we want to get rid of the radical. In order to get rid of the radical, we are going to square both sides. So we are squaring. And if we are squaring both sides, let me write a little bit with a longer step here, I think, because we need here to see what we are doing. So I have minus x in a square. And here I have everything is a 6 times square root of 2x. 6 times square root of 2x. This is a square. And if I'm squaring minus x in a square is going to be just a x squared, because minus x times minus x is a x squared. So this is going to be x squared. And what's going to happen in the other side? If I'm distributing 2 in exponent 1 here, it's going to be, because 6 has in exponent 1 here, invisible 1, let's say here. And if I'm distributing this, 2 times 1 is 2, so 6 in square is 36. 36 is here. And this 2, if I'm distributing here, is going to simplify this square here, and it's going to be time 2x. Time 2x. So finally, this is going to be x squared is equal to 72x, because 36 times 2 is a 72x. Now we are in this position here, but when we solve, and as we see, this is quadratic equation, is a binomial because it has just 2 terms. We already see, because it's missing the constant here. And in order to solve a quadratic equation, we know we have to make in one side a 0, the equation. And this is 72x I'm going to put in the other side. So what's going to happen here, I'm taking a shortcut here, so I'm not going to write the whole process, is minus, because it's going on the other side, changes the sign to minus 72x. 72x. And now, in the other side remains nothing. It means it's 0. And now, I am factorizing x squared minus 72x. If I factorize, it's going to be x and factor of x minus 72. Which is equal with 0. And looking from this perspective, we know x is equal with 0. This x here is equal with 0. And the other here, x minus 72, we already see the solution is x is equal with 72. So the mathematical process gives us these two solutions, but we have to check in the original equation. And if we are checking here, let me write it with a different color so you see what I'm doing. So I'm checking the first solution, this solution here. Let's see is it valid or not. So instead of x, I'm plugging here 0. So here is a 0. Let me write everything. So 0 plus 9 plus 9 is equal with, is a minus, I'm sorry, is 2 times 0. 2 times 0 is 0, is equal with 3. So 0 plus 9 is 9, and square root of 9 is just square root of 9. Let me write here because I want to write everything. And minus 0 is 0, right? Because 0 plus 9, square root of 0 plus 9 is the square root of 9. Minus square root of 0 is 0, so it's just square root of 9. And here is equal with 3. Obviously, we see square root of 9 is 3, is equal with 3. So this is a valid solution. So both sides are the same. So this is a valid solution. But now we look in 72. If we check in 72, instead of the x, I'm plugging here 72. And it's a 72 plus 9. Plus 9. Here is a minus 2 times square root of 2 times 72. 2 times 72 is 141. 141 is equal with 3. And now we are looking here. 72 plus 9 is 81. 81. Here is a minus square root of 149 is not a square number, but I know is 144 is a 12. But let me see in a calculator here if I can find this result. And calculator tells us if we are going 141, and if I'm going with the square root, gives us 11.87. So this gives us 11. Let me write here 11 is 11.8 is equal with 3. Square root of 81 is 9. 9 minus 11.8 is clearly, this is going to be some decimal number here, is a 3, and this is going to be minus 2.8, because 9 minus 11.8 is minus 2.8, and this is a decimal number, is very obvious. This is not the equal, those two signs, and because those are not equal, it means the solution x equals 72 is not valid, and it's not valid, this one. So this is not the solution, is extraneous solution. So x is equal to 72 is extraneous solution, while the other here, x is equal with 0. X is equal with 0 is the only solution here.